Hello, everyone. Welcome to the ABE I4th seminar on October 2nd, 2020. And today we have the pleasure of having with us Assistant Professor Salah Issa. Uh, and he's a professor of agricultural safety and health at the Department of Ag and Bioengineering at the University of Illinois Urbana-Champaign. And Issa's research is focused on injury prevention through predictive algorithms, evaluating new technologies and implementing technologies that reduce or remove hazards. And his specific focus is on digitization and some of the new transformative technologies that are coming to ag as a result of AI, and how these technologies will affect agricultural safety and how we conduct the safety. So I will hand it over to you, Issa.
Thank you. Thank you, Girish. I truly appreciate it. Let me share my screen. There we go. Okay. Well, thank you, guys. Today, I'm in a sense talking about agricultural safety from a new paradigm. 2-3 weeks ago, you had Josie. She started talking about agricultural safety and veered into stress, which is becoming a very hot topic. So now I'm looking into, in a sense, the other side of agricultural safety, and I'll get started. I'll first start actually with just a bit about me. Okay, there you go. Now it's working. So I've been a bit all over the place. So I got my bachelor's in biochemical engineering from Rutgers University. Worked a few years in consumer products and biotech, so I had a lot of exposure to how deodorants are made, lotions, soaps, also ways that companies try to entice customers to buy their products. Seeing that experience made me want to jump back into college because I wanted to do something where I felt I was having a positive impact or leaving a positive legacy. So I joined an interdisciplinary program at Purdue University called Ecological Sciences Engineering. And that actually was the first time I got exposed to agriculture engineering. Growing up in Jordan until basically my mid-teens and then coming to the US, that was not even a field. It's not something I even thought of or knew that existed. And I was immediately fascinated and slowly got my master's there and continued with my PhD. And I was very interested in storage systems because it has a major impact on actually distribution of wealth. You know, you have a storage system in your farms, you have better control of when to sell those products. So I started looking for professors that worked on that, and that's how I met my advisor, Dr. Field. But he was focused on the safety side of things, on grain bins, and that's how I ended up doing a degree in ag safety. So it's been an interesting road, and after that, I worked a bit in software, problem solving, and then later on, I got accepted as a fellow with AAAS Society. They have a Science and Technology and Policy Fellowship. And I did basically a year and a half at USA NIFA, and I got to see basically technology and innovation from the inside, from the government's perspective, which is fascinating, and it really excited me because I saw how all these different areas were starting to merge together. And that excited me, and that's why I applied to IAC, and luckily I guess they like me. So I've been here since January, and I've been probably hiding away, just writing grants, trying to get the program started. And let me get started. Let me share with you some of the ideas and some of the work that I've done. So I'm going to focus really on two big topics. First is looking at agricultural safety trends, and then trying to develop, instead of a retroactive, a proactive view on it, so that, you know, as these new technologies are coming on board, how can we develop a safety approach? And then another aspect is, okay, we have these incidents, we have these data. How can we how can we develop technologies so that we can actually start predicting? So instead of responding to an incident that occurred, we can actually try to predict and stop an incident from occurring before it happens. Because, for example, in the area of grain entrapments, and I'll talk about this in a lot more detail, we get about 30 to 40 cases a year. So it's like and a lot of times we get training requests after an incident occurred in a farm or in a county. But truth be told, the chance that another incident would happen in that same county is, in a sense, very minuscule. So we're doing the training, we're helping, and we're hoping that we're making a difference. But then there's always that question, are we actually making that significant difference? Can we somehow give that material on these topics to individuals that need and want this material or are going to be involved in this before they actually risk their lives? So going into agriculture safety, as Josie in a sense talked, it is about 23 fatal incidents per 100,000 workers, which is currently the most dangerous occupation in the US. And that actually translates into about 600 cases per year. It's still actually one of the higher ends. But there's a bigger story to it. It's not just a static number. So if you look at this chart, this is incident rates over time. So I picked what is considered the 3 top or riskiest industries, and that is construction, agriculture, and mining. And you look at their incident rates, the number of fatal incidents per 100,000 workers over the last 30 years. That's what basically we have data from the Bureau of Labor. And what you see is that originally mining and farming were just as risky. Sometimes farming was on top, sometimes mining was the riskiest. But something shifted where, especially after 2008, 2009, mining got a lot safer, but farming has remained relatively stable. And I've put basically trend lines, just linear trend lines, just to show you in a sense of stability. Like, yes, you had this peak in the middle, and that actually is part of how they calculated data. But overall, for agriculture, it's been fairly stable. The incidence rates over a 30-year period where construction and mining has been declining in terms of number of fatal incidents. So that's concerning. But yeah, that's one part of the picture. The second part of the picture is actually looking at the number of fatalities. And you see with farming, we start in the 1990s with about 850 cases per year, and now we're actually down to below 600 cases. So we've reduced our caseload by about 200 cases per year. While for example, mining, they used to be about 180, now they're closer to about 130. And construction basically has been going up and down a bit all over the place. So it's telling us, in a sense, so you have basically these two different disparities. On one case, the number of our cases actually are declining in agriculture, but then the number of our incidents have been relatively stable. And the first thing that you're thinking, okay, this is probably due to we're becoming more productive, but can we calculate it? And and here, in a sense, in these figures, I'm just re-putting the same graphs, the fatal injuries and the rate, but just keeping them alone, just so you can more clearly see them. And again, it becomes a question, okay, so that probably, the reason why our incidence rate is stable, it means that agriculture is not becoming safer overall, but it's just that we need less workers. Or that because our cultivars are more productive, we need less land, which in a sense translates back to less workers. And so that's probably, in a sense, the hypothesis. And luckily, because of the data that we have from ERS, we can actually go about calculating it. So with ERS, they have, in a sense, the labor value. They have data from the 1980s of our labor force, both in terms of labor value and then actually in terms of the number of workers and farmers and that are working in it. We have, in a sense, the land value. We have also the agriculture output value. And you can clearly see here that the number of our workers has decreased tremendously. And the land that we're operating, the farming, actually has also decreased from about 1,200 million acres down to basically about 800 million acres. And then our agriculture output from basically 1960s to now increased actually about fivefold. So we see that in a sense in our data. And what we can do is that fatal injuries, to calculate the number of fatal injuries, it's basically a function of the fatal injury rates multiplied really by the number of labor. And you determine the number of labor by basically how much land you have and how much labor input you need for that land. So using these three figures, you could calculate the predicted number of fatal injuries just using injury rate times basically labor efficiency times the land input. And if you look at this on a year-to-year basis, and you hold two figures constant, take the average of two, because it doesn't change that much year to year. And then you take the difference of the third term, and then you sum that over the time period, you could actually get the predicted basically impact on, like for example, production, becoming more productive equipment, how much did that reduce? How many lives did that save? Or if we became more safely conscious, how many lives we saved there. And similar, if we have better cultivars and reducing the land input, how many lives we saved. So doing that, you generate, in a sense, an interesting curve, interesting graph, where you find that engineering developments, which in this sense, because a lot of times when you're developing, for example, equipment, there are safety components, or you're trying to make it safer as you're trying to improve it. But in this sense, just looking at the engineering developments, basically auto steering or more productive or bigger tractors, or bigger grain bins, and that all as a whole, it's basically, it could have counted for basically about 172 of that 300 gap in a sense. Safety enhancements was basically about 76 lives, and then yield improvements, from the one sense, it's 27 lives, but when you think about it, if the yield improvement did not occur and you had more land that you need to harvest, then that would have cost an additional, or saved basically additionally 121 lives. So in essence, the safety enhancements, at least from 1991 to 2016, played a minor role actually in reducing the number of injuries. And that makes sense in a sense. That's why our overall our rate has been stable in terms of the number of fatalities per 100,000 workers. So, but then that feels like a missed opportunity, because it means that in the last 30 years, even though we've done a lot of work, we've put in a lot of resources, it's not so clear that we're able to reduce safety. And that's why, in a sense, we know, for example, this new revolution is coming. Can we be proactive and be involved from the start to try to include these safety components, so that when they are on the market, or when they've dispersed and reached a significant amount of the population, it actually does reduce the injury rates. And speaking about AI, this is in a sense a source from USDA. USDA is looking at, and they're defining AI very broadly. It's from, artificial intelligence, machine learning, computer vision, precision agriculture, digital agriculture is probably a better terminology. They're looking at it that it's basically can transform agriculture, and they've indicated that they believe basically every year an additional $45 billion of added value will occur due to these technologies. And a lot of that is in livestock and dairy production, but row crops does play a significant amount, and so does specialty crops. And you could see that from the technologies that we're developing here and developing at other universities, from whether it's just monitoring the health of livestock, looking at our row crops. For example, here we have our little, and Garish knows the name, I'm sorry, it just slipped my mind. I've been in too many Zoom meetings, but our little machine that goes between rows that can, I'm sorry?
You're talking about the robots?
Yes.
TerraSentia.
Thank you, TerraSentia. I just don't know why, it just slipped my mind. So for example, TerraSensia and its ability to, in a sense, do remote diagnostics or monitor the crops, that all is expected to contribute a significant amount as added value to agriculture for the next years. And this is something that, but being on the inside in the government, I could see that they are taking it very seriously, from basically developing a strategic plan for AI that they published basically a second edition for it last year, producing the website, investing money into for example, into basically governmental organizations, for example, the NSF AI Institute, which congratulations to the team here at the UIUC for actually getting it. So that's basically, there's going to be a lot of money into this, and they are expecting this to grow big. And that's advantage from an agricultural safety specialist. It's like, how can we get involved? How can we contribute here and now, to improve our system, so that when we're looking at the other end, we have, in a sense, a safer, more secure farms. And to me, the biggest example, or the biggest thing I think about when I think of agricultural safety health, like retroactively, we think of tractor ROPS. This is still a significant issue. You have, I think in the 1990s, you had basically 100 fatalities or 100 cases per year of basically the tractor rolling over. And now more currently we have ATV safety issues, but in a sense it's all reactive. We developed these technologies, like tractors came out, or they're older technology, but they really came out big, and they really changed agriculture really basically during World War II, and they were trying to save up every possible amount of steel that they could to put it to the war effort. So I wonder if, because that definitely had an impact on design of the tractors, and I wonder if it had an impact on actually setting up a ROP system. But then now they're in our environment, and we're talking about 50, 60 years later, even though we have tractors that are safe with ROPS, and that's all part of the law, you're still seeing these incidents. So that shows like how much I pulled, like how important it is to reach a technology at the very beginning, before it's widespread. And we're actually starting to see cases with AI. So in Fort Wayne, Indiana, there was I think it was an autonomous tractor or a self-driving tractor. The farmer in it fell asleep, and it just kept driving through, and it plowed through the playground. Luckily, there was no kids there, and just basically went through his house. And that's actually being litigated right now, so I can't talk much about it. And so that's something, that's a lot of things that are happening. And our focus has been a lot on farm safety and farmer safety, basically. That's what I call it, or worker safety. And what we see in the last few years, there's a realization that it's not enough to make sure that he's physically healthy, the farmer. There's a lot of stressors that impact their safety, that impact the decisions they make to stay safe, that we need to study as well. And there's in a sense, to me, there's a bigger circle, because if you're really focused on farmer safety, you have to look at basically agricultural security, or keeping that farm safe. And that's where I'm curious about, in a sense, a lot of AI technologies, because we're developing these systems, and I'm wondering, a lot of my thoughts is about what happens when they fail. What systems do we have in place that protect us when these systems fail? And it could be a big failure. For example, a autonomous tractor loses GPS, or goes off field, or does whatever. Or it could be even smaller, like our sensors are giving us the wrong data, and we're acting on this wrong data. So that's in a sense some questions. And luckily for us, and congratulations to Dr. Shodhi again, with the DPI funding, we have a Center for Research on Autonomous Farming Technologies. So that's my hope, is to work with the team to look at these safety and security hazards, look at how can we protect our farms and our farmers. So in a sense, it's my first part. That's basically, vision for AI in agriculture is really partnering with other faculty, exploring these technologies and how can we build them from ground up to save lives, and maybe discovering new areas of innovation. For example, I can pull in what is our biggest risks, what's causing most of our fatalities, and maybe there's a system, AI system, that can actually help reduce that. So that's in a sense one vision that I'm hoping to build on, and excited to work with the team on more. And the next vision is really geared towards basically predictive analytics. So we have a lot of data, weather data, soil data, moisture data, that's starting to be generated from our farms. The goal is to make them data intensive, so that we could, in a sense, build our machine learning systems and build our computer vision systems, so that they can actually operate the farms at efficiency that we could not imagine before. And to me, it's like, is it possible to use this data to, in a sense, use it towards safety, towards predicting injuries, towards protecting our farmers and the farms? So a lot of my thought actually comes into predictive analytics. Actually started at the CDC with their One Health initiative, where they've tied basically tied having a healthy environment to healthy people to healthy animals. That you need all three that working together in tandem to actually develop, I guess, healthiness for everything. And they gave us some very interesting examples. So, for example, in Yemen, they've been using this basically weather data and population data to predict the risk of cholera, basically infections and cholera epidemics occurring at local sites, and they were able to reach like a 92% accuracy in these predictions. And that becomes critical, because especially with Yemen, it's war-torn. It doesn't have the facilities or supplies or personnel to go and do this nationwide campaign. So when you have these type of technologies, you can now start doing directed interventions. So you can focus on the cities or the regions that are most impacted, and you can target those to basically make a difference and maximize the benefits that you can make given your limited resources. And it's not just, and the first thing is like, oh, this is probably a fluke. It's just the way the bacteria works that we could track it, but it's not the only one. There's also a fairly recent disease. It's called chikungunya. It's a mosquito-borne virus. It's spread really rapidly the last 10 to 20 years. I think maybe 5 years ago, it reached the Americas, started in East Africa. So what they realized is that both from the virus perspective and the mosquito perspective, that they could, in a sense, predict risk based on air temperature, rainfall data, land surface temperatures, humidity, soil moisture data, the human population density, and looking at that and being able to predict risks, they can, and they do these risks on basically a monthly basis, so they can tell the states or the countries or the counties when they need to launch their campaigns to try to reduce the severity of the outbreak and basically reduce the impact. So that in a sense made me think, well, what about agricultural safety? We are very similar to a lot of these cases. We have limited resources. We only have so many dollars and personnel available to do training. We're always constricted on that. And then on top of that, when we're doing training, there's always this question is, can we enforce or can we change that behavior? Because in a sense, we're doing training for the ones who want to be trained, not necessarily who need to be trained. And there's a matter of basically, it's a motto in agriculture safety, is that we call every fatality or injury an incident, not an accident. And the reason why we use incidents is the idea that it's preventable. We could have prevented this fatality or injury from occurring somehow. Well, an accident, it's basically you're invoking an act of God. It's like an accident. There's nothing you can do. So thinking about that, I started to think about, hey, what about my specialty, which is in grain safety? That's what I basically got my PhD in. And looking at grain entrapments, since we have a wide variety of individuals, I'm just gonna spend about 5-6 minutes talking about what grain entrapments are. So grain entrapments, they're basically, driving down the highway, you probably see these big steel bins along the highways. So these are filled with corn, soybeans, and wheat usually. Depends obviously where these are located in the regions. And what happens is, in a lot of cases, is that a farmer is trying to empty his bin, it clogs. And it clogs because basically a clump of corn or a clump of material goes all the way down to basically the auger here at the bottom, and it clogs it. So usually the farmer goes in, brings a long rod, and he basically is trying to unclog it. But what happens when he unclogs it, it starts flowing. And usually is right at the center where it starts flowing. And a lot of times farmers don't realize how quick that is. It takes basically 4 to 5 seconds to be entrapped at your knee or thigh levels. And when you're there, you can't actually self-extricate anymore. You're stuck. And it doesn't take more than 20, 30 seconds and you're fully buried in that grain mass. And this is, in a sense, the most common way. We call this method the flowing grain, though we've seen different ways that they can get entrapped in grain. And why do you have these clumps that occur? It's usually because of bad grain, in a sense. This could be they put grain that had high moisture content and got moldy. So there you see basically a tower of bad grain that's like 65 foot high. And we do have other cases where you have workers that go at the bottom of the tower and they're trying to ship away, and it just collapses on them. So basically, so you get all this bad grain. It's high moisture, hot temperatures. Maybe you had a hot winter overall. You had maybe too many fines that basically speed up it going bad. And so there's a lot of different ways it goes bad, but that's in a sense that starts it. That it going bad is really a condition of the environment around it. It's a lot of times there's some years where you have very wet harvest seasons that occur very late in the season. So you're harvesting very wet grain. You don't have the time or resources sometimes to dry the grain properly. And that's when basically problems start. And just talking about this grain entrapments, there's, we've seen over 1,100 grain entrapments since the 1960s. So they're pretty relevant, but if you do the division, it's about 30 to 40 cases per year. Majority is really structured around the Midwest. So Indiana, Illinois, Iowa tend to be some of the higher states. Wisconsin also is up there. It's really involves a lot of youth. Can you imagine basically about 25% of the cases that we've gathered historically involve youth under the age of 21. And then also another 25% is adults over the age of 60. So it involves a lot of the age groups that technically, if this was any other occupation, they wouldn't be really in that field. And it tends to be very fatal. Basically, over the whole database, we had summed up a 67% fatality. In the last 5 years, it was about 42% fatality, and that's, if you do a bit of comparison, you look at the number of injuries that are recorded by ocean in agriculture versus fatalities. Agriculture as a whole has a 0.7% fatality rate. And this is a study I did, basically calculating the amount of force if you're trying to extract, assuming the farmer or the worker had worn a harness beforehand, which is usually a lot of times not the case, sadly, but it takes about 4 times a person's weight to pull him. And to do that, in a sense, to get a sense of what that means, I went and got some basically lamb spine, and I tried to pull it apart to see how much force I needed to pull it. And I found out basically it takes about 2,000 newtons or a force, which is equivalent if somebody's buried at chest depth in a sense. So that's pretty significant. It shows you just how much force is involved, and there's also basically a lot of chest pressure on it, makes it hard to breathe. So for example, when I split the cases between you're fully engulfed, you're completely under the grain, versus basically your airways are above the grain mass, you see for engulfment, it had 88% fatalities, and then for entrapment, 7% fatalities. And 7% sounds, wow, that's great, that's not bad, but then why would you even have 7%? The person's airways are visible, are there's no grain in them. And that's because really, in a sense, you're experiencing crush asphyxiation. The person can't breathe, he can't push his lungs against the grain mass. That's where you see it. So that was a very quick and in-depth introduction to grain entrapments. And here, in a sense, going back to our predictive analytics, here you have the number of grain entrapments by year. You can see that basically in 2010, we had 59 cases. And that started a lot of, I guess, the modern focus on grain entrapments. OSHA funded a couple of grants. The Grain Handling and Safety Coalition started, which, by the way, University of Illinois was a co-founding partner for it. So you had a lot of work on it. And you look at the number of incidents, actually, even more on that, a lot of curriculums were developed. Maybe at least 4 different curriculums were developed just on staying safe in grain. And in this sense, it seemed like, hey, we're working. The number of grain entrapments decreased from 59 to 33 to 23. And it seemed it's working, but then suddenly stabilized. It started increasing up and going up and down. So what's going on? It seems like there's other factors at play, not just necessarily us doing training. And if you look at it per year in terms of precipitation, because I was very interested if it was what harvest. And this was prepared by a colleague of mine, by Hamza, in crop sciences. And this is looking at precipitation for the whole year. So it's not a precise comparison, but you could see in 2010, we had, especially in Illinois, we had a very wet year. Actually, this is 2009, which in a sense represents the cases we're getting to at 10. You see in 2012, we had a very dry year. So that has an association with the reduced number of cases. You could see in 2018, we had another very wet year, and that might have impacted the 2019 incidents. And now, in a sense, we're looking at basically last year, 2019, which was also a very, very wet year. And again, we're seeing record number of incidents. So we've documented internally at least 38 incidents occurring, which would basically put us among the highest. And I'm pretty sure that we're going to end up being the second highest incidence since 2010. Also, similarly in Illinois, we've already documented 5 incidents in Illinois itself that I've measured myself, and that is the second highest. Because in 2010, when we had those 60 cases, approximately, about 10 of them were in Illinois. Okay, so it seems like, in a sense, this is at least ripe to study to see, can we build those correlations? And there's other correlations, not necessarily just environment, because it plays a big role, but it's not the only one. So if you do a correlation between number of incidents versus the number of farms with grain storage, you can see it's a very strong correlation, actually. Indiana in this study was an outlier. And the reason why it was most likely an outlier is not because Indiana is less safe than other states or more risky. It's more a reflection of where the data is collected. Dr. Field and we were based basically in Indiana, so that relationship with farmers, they were giving us incidents, especially like near misses or incidents that they survived in. So that's why we probably have inflated number of cases in Indiana. But that actually points to another question, because the rest of those cases, the way we collect them is actually Google Alerts or news clippings, which means that basically a media company had to write a report, write an article on this incident, somehow captured the spotlight for it to reach us, and we just don't know how many cases we're missing, because that's just a limited way to collect data. So it's very possible that our trend line is much sharper, higher, closer to where the Indiana is, and we have a lot more cases than we realize. And a more just general factor, we held a training on grain safety recently, and we polled 15 individuals. We were just evaluating the effectiveness of our training. And we just asked them, like, did you experience an incident where our training helped you or not help, or did not help you? And we had basically 12 people that said they experienced a near miss or incident, including one fatality and a grain entrapment. That's such a small sample size. And we did this training in April, and we just asked them, in a sense, last month, since the training. Of course, so it shows you that there's probably a lot more incidents that we're not capturing, in a sense. And there's probably also economic factors, the price of gas. If the price is high, would I rather warm my house or dry my grain? The price of corn. If the corn is really cheap, how much more am I going to invest to dry the corn? There's also yield factors. So years with very high yields, where are you going to store the grain? You tend to store the grain on the floor or in other conditions. So in a sense, I feel like we have enough data that this could be ripe for doing a predictive analytics. And that becomes a vision, is that can we work with extension to basically predict grain entrapment risks, like where are the counties, where are the states that are at high risk in a given month or year for grain entrapments, so that our messaging can be directed. We can say, we can focus on these states and these regions and hopefully actually prevent these entrapments from happening. But to me, that's just really starting, because I'm really curious about other agriculture incidents. What other factors, whether it's demographic, environmental, that we can analyze to understand where the risk is. Because if we can understand that better, then we can, in a sense, direct our training. And lastly is, there's a lot of data streams that will be coming out and are coming out from farms So how could we use them to basically analyze these safety risks, or develop these predictive analytics? So that's in essence these two very broad visions I'm working on, and it's really a very bright day for agriculture. AI will definitely transform agriculture, but we have to think as we're developing these technologies, how can we keep it safe for the farmer and also safe for the farm, so that our farmers don't have to make these difficult or impossible choices in a sense in terms of staying safe. And this is something I believe, and that's why I was really happy when Girish invited me. Basically, agriculture safety specialists must play a role in these development of these technologies to help and make sure that we're actually making an impact. And that's it. Thank you. Open to questions.
Thank you, Salah. Issa. Sorry, I always keep confusing
No,
your
Salah
first
has
and
first
last
name, so
name.
that's good.
Yeah. Okay, there are some questions here. So first one is, would you not argue that some of the engineering improvements were due to safety requirements? I think this was asked a bit earlier, so I don't know, maybe the person who asked it can elaborate?
Yes, well, in terms of improvements, yes. Absolutely. For example, just ROPS or tractors, like the requirements on them to become safer, or even just, was that a year ago or 2 years ago, for example, we passed a new grain bin standard with the ASAB. So yes, there are improvements going on, but in a sense, if you look at the way we calculated it, we are, just by the way you calculated that portion on engineering, I was looking at labor over land, like how much labor you need to work on a land. So that is just basically geared totally towards just having a more productive piece of equipment. Because that was a question, is that how safe did we actually make farms are? And so that's why I did it that route, and we ended up with a result that not as much as we expected.
There are other questions?
So, sorry, what I meant by that question was, in engineering and building of equipment to be more efficient, there was inherently safe standards and stuff that were put into it. So there is a factor of what safety has been contributing to it that also helped with that inherently safe activity.
And I don't disagree with you. This is why, in a sense,
I mean, I really like the analysis and I agree with it, but I'm just not sure it's quite as clear cut in that graph that you just went through.
So there's this, these safety enhancements, in a sense, that could be very well just from engineering improvements that were designed for safety enhancements. So it's not negligible, but in a sense, like basically looking at the engineering developments, we're just calculating it basically as a function of labor over land input. So it's more of, in a sense, if it really depends, because you have three factors. You can have the more productive cultivars, so you need to plant, instead of 10 acres, you need to plant 8 acres. You need less, not necessarily less workers, but less basically hours, contact hours you're spending on that farm. So that's one way of safety, one way that you're actually reducing fatalities. Another thing, you have your tractors or your systems. You can output more per employee. So then you're also, in a sense, reducing contact hours, which in a sense you are saving lives, as we saw, but it's more out of basically the productivity development. And then the last one is fatal injuries per labor. That rate, that is what determines basically that systems that you have, especially from a large scale. Like if you have 100 fatal incidents over 100,000 workers, you have that specific rate, and that rate, in a sense, it's in a sense generalizing, but it's basically looking at just, did you make is farms or is agriculture safer in terms of the worker contact hours, basically how much hours you're spending on the field. So in that sense, and you know, this is a very general analysis. So it's very likely that, for example, and that's something I actually would like to do and work on. It's very likely that maybe in one area, like for example, our tractors, that we could argue that become super safe, but that exposes risks in other areas. So that's also possible. We're not really looking at that dynamic between, you know, your grain storage, your fertilizer, your all the different systems are basically on the farms. Does that help?
Yeah, thank you.
Isa, I had a question about the autonomous tractor incidents. Is there any kind of documentation or reports on that? Like, and this would this be like one of the deployed systems, or was it an experimental tractor?
That's something that is something I basically gleaned from the network that I work with on and other ag safety professionals. So it's actually currently in litigation. So there's it's I haven't been able to find a lot because I was very curious. What was the system? What was the technology? What was going on exactly?
And there was no news about it anywhere?
I am sure it's somewhere. It's but that's the thing when it comes with news, that if you're not tracking it in advance, it tends to go under radar very easily.
Hmm. Yeah, it would be very interesting to find out more details on things like that.
That's something that is one of my projects, is actually developing basically a Google Alert system to start capturing that data. You know, as it comes in. That's really the most effective. But even that, I mean, I didn't include this graph, but for example, when it comes to grain entrapments, we end up finding cases years later. So originally for 2010, we had actually 51 cases when we reported 2010. And just over the years, it just more cases popped up for whatever reasons. And we started building it to the point where we had basically 59 cases. And that's, in a sense, especially when it comes to reporting agricultural incidents, that's really one of the hardest aspects, especially with a lot of the regulation and the exceptions and stuff like that. We tend to find that's very hard. For example, also, I did an analysis, for example, OSHA, like our data on 600 incidents, for example, right, on OSHA that they reported for fatalities. I was looking at what they had in grain entrapments, or that category that could fit into grain entrapments, compared to the number of grain entrapments we were collecting at Purdue based on Google alerts. And we had at least, if I remember correctly, at least the number of incidents we had reported was fivefold what was captured in the OSHA's data set. Cool. So that's really one of the hardest parts of this.
Yeah. Any other questions?
Yeah, I've got one.
Yeah, Cody.
Yeah, so I really enjoyed that presentation, Salah. That was fantastic. This is really important work. My question is on the towards the end there, you were talking about grain entrapment, and you had a lot on the number of farms versus the incidents. I was curious, and you may have talked about this, I missed it. Have you looked at the size of farms or some of the other demographics?
I was more interested into, so the way that NAS reports the data, it's not really the size of farm, but it's basically the number of farms at different grain bin levels. So they have basically grain bin capacity 5,000 to 10,000, number of farms. Grain bin capacity 10,000 to 20,000, number of farms. In this case, I summed it all together, and that generated pretty good data. I've tried it at different, I don't think I've tried it at different grain bin sizes, But what I did try is, because we also have commercial grain facilities versus farm facilities, and you get, in a sense, identical results almost. It's the same graph, same correlation, same strength.
That's interesting. Yeah, that's almost actually surprising. I would think that the commercial grain facilities would be much lower. So the reason why I asked that question is, if the goal is some sort of prediction to know where to focus your training or your extension at, I kind of hypothesized that larger farms would have less issues with this because they're more likely to have grain dryers in their grain handling facilities, and they'll dry it before they put it in there, whereas your smaller farmers probably a little more likely to put it in wet and try to blow it out with just air inside the bin, and that'll get you into trouble. So I wondered if there was similarly the availability of local elevators and their grain drying could really have an impact. It's neat stuff.
Yeah, it's hard in a sense to parse it out, because again, these are basically, you're talking about 30 incidents per year over the US. But what I could tell you, year to year, we were looking at basically the OSHA status, but to best of our knowledge, based on whether it's a commercial facility versus a farm. Historically, it was about 70% farms in terms of incidents, but when I was plotting it over the years, it's much more dynamic. You had years where 60% of the incidents occurred at OSHA regulated facilities, or basically commercial facilities like elevators and stuff like that, while 40% of farms, and it just keeps oscillating actually. But yeah, there's a general assumption that these don't occur at much lower frequency in commercial facilities, and that's not fully true. It's still occurring a significant portion in commercial facilities.
Interesting. Thanks.
Yeah, there you go. Any other questions I can answer? This image here behind me, I just put up this morning, so it wouldn't be a blank wall. That's actually basically a graph of the history of the world, though you can't see it. Maybe one day I'll take a picture of it. Yeah.
I have a question.
Yes.
It seems very unsafe to get on top of a pile of grain. So why are people still doing it? And why isn't there technology that can help people declog their augers?
It's complicated in a sense. I would say, at least from the farmer perspective, there's a lot of do-it-yourself attitude. I know myself, I have that. If I have a problem, even if it's plumbing or even I don't know anything, I try to solve it first. So I think a lot of it is that. There are some ideas and technologies of how to reduce it. So for example, in Iowa, there's a farmer that he generally takes really good care of his corn, and he had a year where it's just bad and his things clogged. So he used basically air compressor to try to remove the clogs, and that worked for him. But there hasn't been a lot of studies on the efficiency of that. So it's hard for basically safety professionals to promote, for example, that type of technology, because you don't know the risks involved, especially when you're using high pressure. You don't know if the grain bins themselves can handle it, or there's just so many factors. It's a lot of factors, especially when you're talking about human behavior. Why does a human do what he does? It's complicated at the very least. I know that's probably not the answer you're looking for, but there's just it's a lot of factors actually.
Lots of opportunity for ag engineers to step in and solve some of these problems.
There is, and the in terms of ag engineers, a lot of the struggle we deal with is really the age of the equipment. So generally, but this is anecdotal evidence. We don't have the data to do that study, but when we did evaluate grain entrapments, we've seen that there's a good percentage that occur at basically old facilities. So that's, and the problem becomes with all facilities is, especially when it comes to grain bins, they're not equipped with anchor points at the center of the grain bin where you could basically tie a harness to it. And so you have for farmers, they're a lot more limited in terms of the options they can do. And we've seen cases where farmers would tie ropes basically against ladders. But ladder is basically generally can withstand the 300-pound force. And as I showed there, you can get over 1,000 pounds force when the grain is pulling you. And we have had cases where ladders were ripped straight out of the grain bin. We had also cases where a farmer tied a rope or a harness basically to a roof beam, and that ended up basically coming down on him in a sense. So there's quite a lot of forces, and a lot of the old technology, in a sense, is not cannot support it. Penn State is trying to do research to see what we could do with these old technologies, and that's a factor they run into, is even if they can test the effectiveness or test that it can be used safely, you run into the issue that liability. You don't know anything about this bin, and not very many structural engineers would be willing to take risk with these bins as well. And similar with manufacturing bins, that's why they don't install anchor points at old bins. It's because of liability issue.
Okay, so we're up on the hour. We will upload the video on Piazza. If you have further questions, please keep asking. This is very important. I should see a note here that this is very important work. So thank you once again, Issa, for presenting, and we hope to hear more from you.
Yeah, thank you, Girish, for inviting me. I'm looking forward to working with you, and looking forward to this work.
Okay.